specialty hydraulics and electrics, some of the vessel operators, those building cable factories, and that will help to drive further inward investment all around the estuary.
Are the first signs of an economic upswing due to the energy transition on the horizon?
We are seeing this growth accelerating around the Blythe estuary. So the Port of Blythe is very much part of the town of Blythe, and the community is very much with the port in what we're doing here. They see the jobs coming in, they see the benefits to the economy, and looking to the future, we're going to hope that the majority of those jobs will go to local people, so they are very much with us.
The world's largest network to reliably generate energy has been under construction in the North Sea since 2020. In order for a new energy economy to succeed, it's crucial to build large green power grids that are stable. By becoming partners in a new North Sea grid through direct coast-to-coast lines, border countries are inching closer to the goal of attaining energy security.
Europe has to be able to collaborate even better. I think every European state leader and the European Union leaders, it has dawned to them that we need to collaborate much stronger than we ever thought that was possible.
This North Sea grid will deploy the latest technology to exchange generated energy back and forth on demand. Large industrial centers will be built at the hubs, like this planned energy island off the coast of Jutland. More should follow and be interconnected. In the future, they could form a kind of inner network on the high seas.
Essentially, it's an artificial island that can be expanded over time. But what is really great about an energy island is that it can actually power different countries around the North Sea at the same time.
The first of these energy islands is to be built about 80 kilometers off the coast of Jutland, and according to the latest estimates, cost more than 30 billion euros. It is the first of several hubs for the new energy sector. The island alone should one day provide electricity for up to 10 million households. This will require large substations where alternating current can be converted to direct current and back again. That's vital to transmit electricity over long distances.
It started very much as technology that would help integrating large bulk power and transmitting long distances with a much better efficiency because of much lower losses. The more systems we integrate, the more complex the entire energy system becomes. If I need to integrate the next 20-30% of electrical vehicles into the electricity system, if I need to integrate 40, 50, 60 gigawatt worth of offshore wind, there is a need to anticipate the planning and investments in order to deploy the grid technology on time.
60 gigawatts is roughly equivalent to the capacity of 40 nuclear power plants. On the eastern coast of Britain, construction on a new power cable was recently completed. It connects the grids of Britain and Denmark and will supply them with electricity from both countries' offshore wind parks. The new interconnector between the two countries is called the Viking Link. With a length of 765 kilometers, it's the longest subsea power cable in the world. To meet an ever-growing need for energy in the future, large storage facilities will be required in addition to transmission infrastructure. Hydrogen has immense potential as a storage medium for green electricity. At a Siemens Energy site in Berlin, a simulator shows the total demand for energy in a complex industrial society. Hydrogen could become the new optimal energy carrier, which means the technology to produce hydrogen already holds great strategic significance, even if the industrial infrastructure is only just being built now. One way to make hydrogen is via electrolysis, a process that uses an electric current to split water into hydrogen and oxygen. The electricity to carry out this process must come from renewable sources so that its production is sustainable, and they integrate into existing economic cycles relatively easily. Anne-Laure de Chamat is a member of the executive board of Siemens Energy.
The whole idea is to have a modular system where you can actually add them to each other. So it's the same building block, but you can add them to each other to be able to reach the right scale, the gigawatt scale that is needed, and really stick and be very able to adjust to the demand of our customers, depending on if it's a small industrial site or a very large utility scale hydrogen production.
In the future, an industrial site could use electrolysis to secure its electricity supply with hydrogen storage. How much is needed during daily peak hours? How much hydrogen would it take to replace a conventional power plant, for example? These estimates can be used to determine the best energy alternatives. Hydrogen is available in virtually unlimited quantities and could become the key to future supply.
I would say there's maybe 3 levers for the energy transition. The energy efficiency part, which is reducing the energy consumption by really going there and finding everywhere where we can have a recycling of the energy that is produced. Then electrification everywhere where it is possible, because this is going to be the cheapest way to decarbonize. And then hydrogen and green molecules, where this electrification would not be enough and where we need to capture that to be able to store it and reuse it elsewhere or in processes.
But hydrogen can do more than that. It can be further refined with CO2 into new fuels. Until now, these fuels have been supplied primarily by fossil fuels and heavy industry. The hope is that hydrogen can be the basis for a whole range of fuels in the future.
Hydrogen per se will be used as hydrogen, but a lot will also be transformed into what we call e-fuels. So where we capture carbon that we mix with this hydrogen to then be able to do, in a synthetic manner, any of the fuels that you know today.
Professor Bernd Resch is the scientific director at the Helmholtz Center in Berlin. He oversees projects that use BESSY, a particle accelerator. BESSY is used to conduct targeted research into energy conversion and storage mediums. That includes making solar cells more efficient and refining hydrogen into new fuels.
Seit wann weiß ich oder bin ich überzeugt, dass man etwas ändern muss an unserer
Since when have I been convinced that something about our energy system and energy supply needed to change? It was simply the idea that the physical potential of renewable energy is great enough to supply our planet and humanity, and that it's relatively easy to achieve. That's what convinced me and has gripped me ever since.
Und auch heute nicht mehr losgelassen. Wenn wir das jetzt
So, to translate that into modern materials and technologies, we can convert the energy of sunlight into electrical energy.
Energie des Sonnenlichts
And that energy we can convert into green electricity.
können wir wandeln.
And then we can, for example, use electrolysis to split water into hydrogen and oxygen.
Können wir dann zum Beispiel über Elektrolyse, indem wir
And through this process, we have chemical energy carriers that we can use.
chemische Energieträger, die nutzbar sind. Und wenn wir das
And if we think big picture, we could be in the position to, for example, bind hydrogen to CO2 from the atmosphere and then generate synthetic fuels.
binden, könnten wir dort dann auch synthetische Kraftstoffe generieren.
Sonja Kalnen leads a research project at the Helmholtz Center. The goal is to use solar energy and hydrogen to produce cleaner cooking fuels. These could be sold in places where there's no electricity available for cooking, which is the case in many areas around the world. The project is a collaboration between the team in Berlin and the University of Cape Town in South Africa.
I always start from the photovoltaic cells because right now, since when I started, right now they've become something commonplace. And so I tell them, you see those solar cells on the roof? You can use them not only to make electricity, but also to make hydrogen and other things, even to clean water, if you connect them to the right type of chemical reactor. And they provide the power, and then you can almost do anything without needing a diesel generator, for example.
In many poorer parts of the world, wood and fossil fuel products such as propane are used for both cooking and heating. Converting hydrogen and CO2 into a clean fuel